Hey guys, Bukoid here. I'm going to give you a video. I know I am giving you guys one here in about a week. It's about time for me to make one, I guess, right? Well, I've just been really busy, guys. That's the only reason. There's nothing bad going on in my personal life. It's just been extremely busy. My in-laws are in town right now, so trying to spend some time with my family and stuff like that. But that is the reason. There's nothing bad going on, so those of you guys out there that do worry about what goes on when I'm not putting videos out like normal, nothing to worry about, guys. I do appreciate your concern. It does make me feel good, but there's nothing going on, so don't be worrying about all that. So anyway, what we're going to do today is, again, I'm seeing stuff in the sun's corona, and what I'm going to show you was back on the 5th. But it's pretty convincing stuff. So while I'm showing you guys that, I'm going to show you how I get to these tools, okay? At least to this one. I haven't really shown this one yet, how to walk to it, so you guys can actually go look at it for yourself, which is really what you guys should try to do anyway. Even after listening to all of us that do these videos, it's good to go research it yourself and go look at it yourself and make your own, make your own observations and add to it, add your opinion. So what I'm going to do here is I'm just going to walk you through how I, look at this tool. So what I'm talking about is it's the SDO movie player, basically. How I get to it, and I'm going to show you how I do it, and there's other ways to do it. But I go over here to Scott's, excuse me, webpage, and actually he just posted an article here. You guys should really go check these articles out. They're really good. He puts a lot of time and effort into these, and it's very well researched and always well done. But anyway, not only do they have the articles, and I've shown you guys this a lot, if you just scroll down, you'll come to a part on the webpage here. If you're on your computer, it'll be off on the right, but if you're on your phone, it will be about halfway down. And as you can see, he writes articles a lot. So, I mean, and they're all really, really good. But anyway, here's the links to all the stuff, all the tools that we use. He's got it marked as research links. And there's just so many of them right there. You see all those? Okay. How I get to the tool I'm going to show you is I go to I know this sounds weird, but if you go to Stereo Core 2, okay, and you just scroll down, it says resources. You hit latest image. Alright, and then it gives you this page. Okay. Now you can scroll down through here and you can look at all this stuff too, all this data. Alright, but how I get to this movie player, and I'm sure there's probably an easier way. This is just how I do it. You go here and see where it says SDO, Soho, and MLSO. Okay, we're going to be looking at the SDO. So you click on that one. All right, and then it brings you here. And to get to like see the time lapse movie creator part of this, you hit where it says AIA HMI browse data. Okay, you hit that, it takes you here. So then what do? You just scroll down and see where it says telescopes. Okay, there you can pick your angstrom, which is basically the color you're going to be looking at. You just click on that and it gives you all these options. Okay, now, and I've explained before what an angstrom is, so I would point you guys back to a previous video so I don't, take up a lot of time explaining that again. But essentially, it's just looking at this stuff in a different part of the light spectrum. And we see different things according to its light spectrum. Our eye can only see so much, and that's why our cameras and, our phones and stuff are so much better than our eyes, because they're able to see out of that spectrum that our human eyes can't. So it'll see stuff that we can't with our own eyes. So anyway, where I'm going to take you right now is it's the 171, and it even tells you right here, it says AIA right down here, right? That's basically, it's 171, that's the angstrom, and it gives you a color. It says gold. So that's what we're going to be looking at. We're going to be looking at the gold one. But if you went to the 193, it would be a bronze color, 304, red, you know, and so on and so forth, guys. It's really, really pretty simple. So what you do is you have that box highlighted, and you hit done. Okay, then you go up here to the date, and you choose your dates. The top one's the start date. Okay, I already know I'm going back to the 5th. So what I'm going to do is I'm just going to click on the 5th. Then it gives you the times here. But keep in mind, this is all UTC time. So you'll have to convert your time over. Okay, I'm on the East Coast, and I think there's, what, a 4-hour difference. UTC is 4 hours ahead of where I'm at, which is Eastern time. So that kind of can give you an idea of where you're at according to that. But anyway, just choose whatever time you want. So I'm going to go back here on the 5th, like I said, back to 00. I want to start from the beginning. So then you click on that again, and it changed it. You see that? It says 2019 650000, right? Okay. Now, then you got to choose the end date. So, you know, you can pick whatever you want, obviously. But I know I'm just looking at a pretty small time frame here, so I'm just going to go with, excuse me, it's like a 24-hour time here. So you push that box again, okay, and you see how it changed this one, okay. So we're looking basically 24 hours from the 5th to the 6th, UTC time. That's what we're looking at right here. Now, like I said, if you want to change the angstroms, you go there. Now, so after you do that, you scroll down and you hit submit. And it gives you this video. Okay, it puts it in a video form for you. It's a time lapse. Keep in mind it's not real time or nothing, but it does. It's kind of nice that you can watch this because it kind of gives you emotion. It gives you a sense of movement of what's actually going on. So when you get here, if you scroll down, you see these. You got a pause button, obviously. Okay. The plus and minus, you can speed and slow down the time lapse. Okay, so if I'm back here in that slide bar, I can hit, you know, I'll hit play, and then I can slow it down just by hitting the minus button. See how much slower that started going? Okay, and if I want to speed it up, same thing. So I'm just going to pause it, and then if I want to go frame by frame, all you have to do, okay, and you can tell by the timestamp here. All you have to do is hit this button right here. Okay, and you'll see the time. Watch the timestamp. Okay, see how it's moving? You can control it that way. You can't go in reverse, but you can at least go forward one frame at a time. All right, so. Actually, so if you ever back out of that, keep in mind, once you got this 171 selected, you have to go back. If you back out and go back in it, you have to re-enter that date or it won't let you see it. So you have to do that every time. So you just click on that, and if you've already entered it once, it'll show up here. And you just click on that like that. Okay? I encourage everybody to really go mess with these tools. I really do. You'll see a lot. You'll learn a lot. So, back to what I'm trying to show you here today. We're going to be looking up here in this quadrant of the sun. Okay. Now, I'm going to push play, and we're just going to watch it. Okay, I'm going to slow it down a little bit, but so I'm going to hit play. I'm going to go up here because I know where this is at. Now what you guys need to be watching for is kind of like right in here. Okay, I'm not sure if you guys seen that or not. Might have been too fast. I'm going to pause it. We'll bring it back again. I thought I paused that. There we go. Alright. Now, again, what we're looking at is going to be over here, and it's going to be on the outer part of the sun's corona. What you're gonna see is you're gonna see the sun eject some energy, and to me it looks like it's basically illuminating an object again. It's at least going around it, and I'll explain further here in just a second. So we're going to hit play. We'll zoom in. And again, be watching right in here. Okay, and I'll let you know when it gets there. I don't want to speed this up too much because I really want you to see it, because it comes and goes really fast. And this is why it's important to look at bunches of different angstroms, because we catch stuff that we normally wouldn't. Okay, let's see here. Anyway, it's coming here. There it is. Okay, you see that? Now, I'm going to back that up, and we're going to watch that again. Okay? Let's do it again. I'll zoom in. See that right there? See how it's... What it did was, it come out and it was like that. But yet it was moving that direction. Okay? So, basically what I'm thinking is going on here is the energy's hitting some sort of an object here. You see that? And then it goes around it. Now, this... On the SDO, we don't typically see stuff like this, guys. This is why this is odd. Okay, we'll see objects and stuff in here, but we normally don't see it do that. To be honest with you, I've never seen that. Okay? And I do have to say right here that for whatever reason, it seems that we catch stuff on the SDO at these corners. Okay? I don't know why. I don't know why that is. The sun seems to be... Scott's talked about this before. You know, the sun is active more so towards its equator. Okay? So maybe that has something to do with why we do that. But, yeah, that is what it is. And don't forget about this active area. And I'll talk about that here in a few minutes also. But, yeah. I mean, so, I'm going to back out of that. And we're going to go ahead and go over here to some still shots that I took, just so you guys can see it a little bit better. So, okay. Now again, it's kind of hard to see on this one, but it is like this. This is why this stuff is hard to catch. Okay, because it's not easy to see. That's why we don't catch it very often. At least those of us that look at these a lot, we're catching more and more because it's becoming more and more prevalent. But you can kind of see, like, that's kind of what might be there. Alright, see that? Now I got some other still shots that I'm going to show you. And obviously, as that thing was moving, it would, you know, you got to look at this in 3 dimensions too. You can't just look at it 2-dimensionally. So it could be going across the face of something. It could be doing any of that. Now, so what I did was, I just took that shot and started adding contrast and brightness, taking this away, taking that away, and look what this looks like. Okay? I mean, I know that wasn't a very good, yeah, sphere. But yeah, you can kind of see that, right? You know, and something else that I did notice, if you look at the corona of the sun, it stops right here. And it continues on. So why is this showing up right there? It shouldn't unless there's an object there. Okay? That's what I'm trying to say here. So, I mean, you can see that pretty clearly with that. Now, I did go and mess with it a little bit more, and this actually even shows it even better. Okay? That's pretty easy to see, I think. Now, I have to point this out again, like I just said. See how the rest of the sun's corona kind of stops right here? If this was this energy by itself and there was no object there, you wouldn't see any of this. Okay? Something has to be there for that to happen. Because the rest of the sun's corona stops prior to this area. So basically what I'm saying is that if that, if you can kind of look at it and pretend that reverse arc there isn't there, and you just follow an imaginary line from where the corona starts and stops, it would be like this. Okay? So why are we seeing all this stuff here? We shouldn't. That's what I'm trying to say. So if you look at this, again, I mean, look at that. Not to mention that, I mean, what's that? And you can even go any further than that. I mean, you can see that it's some sort of a, man, I don't know what to call this. Now, again, unless you put this in some photo editing, you would never even get it to this point. So that's why we do what we do here, what I'm saying with these tools. So if you're just looking at the regular SDO and you kind of think something might be there, I would encourage you to go run it through some photo editing. I really would. It's not hard. Those are free apps that you can get. You just add gamma and contrast, brightness, whatever you want to do there. You mess with it. You play with it. You get good at it. Okay? It's actually kind of fun sometimes. But what I'm saying here, guys, is that, something came off the sun here energy-wise. What, number one, why is it that shape? Okay? Because in my mind, if something's getting blown off, it actually should be more this shape, not this shape. Okay? I ain't saying that this C shape isn't possible, but in my opinion, it's unlikely. And then for it to illuminate something here in the middle before it even gets to it, okay, that makes no sense to me, unless there's something there. And again, like I said, the rest of the sun's corona, it's stopping back here. So why are we seeing any of this and just in that area? Well, in my opinion, there's probably something there, guys. Whatever that is, we can sit here and talk about that till we're blue in the face. I just know that what I'm seeing here and observing here is, what looks to be some sort of an object in the sun's corona again. Okay? And then there you go, you put that one, okay? Now, to kind of confirm that might be something, I've done this, okay? This is what I do every time when I see something. I try to go to a different tool and see if I can see it on a different tool. Because if you see it on two different tools, especially if it's two different satellites, I mean, it's almost like confirming each other. So I go over to LASCO C2, which is from the SOHO, which is the same view, but it's a different satellite. Okay, and this is that time frame. Look at the timestamp. 5/12 on the 5th. And this is what we get. And the area that we were just looking at would be this area here. And look what's here. It's grayed out. I find that very, well, at the very least, very interesting. So, and again, you can tell, especially on this difference, black and white difference view here on the left, you see how smooth that looks? And we've all looked at this before. They're usually grainy unless it sees a flash. Okay, and that's when we see this. That's when it gets smooth looking. Okay, because the light's kind of washing out away those hard edges from the typical view. So something happened right there at that time. And for that to happen at the exact same time that this happened in the same spot, it just kind of confirms that something was there. Something's going on there. So, just wanted to bring that to you guys and let you guys see that. Now, something else, I've talked about the Schumann resonance multiple times before. Okay? This is a signature that I have never, ever seen. Okay? Now, anybody that's never looked at this are probably asking, what the heck is he even talking about? Okay? Schumann resonance, basic info here, it's the vibration of the Earth. It's the frequency of the Earth. Normal frequency is 7.8, 7.83 usually. And that's what these numbers over here indicate, okay? So 7.83 would be roughly about right here, right? So if you follow that through, that's what you should see. Anytime you see these spikes, It shouldn't do that. That means that the vibration was off. Now, why I think this one's extremely interesting and frankly weird is, why are we seeing horizontal lines? Okay, we should be seeing vertical. So what that says to me is that this is it's picking something up continuously at this particular frequency right here, hours at a time, at the same intensity. Okay, what I mean by same intensity, well, if you look at this, the white and the reds are different intensities. One's stronger, one's weaker. But if you see a white line going horizontal, not up and down, okay, horizontal, that means it's happening in a row, multiple hours. Because here's the timestamps down here, guys. That's 1 o'clock. That goes all the way through, obviously, to the next day. So something was vibrating at roughly 12 hertz at that same intensity for, well, roughly 24 hours. Okay, and we've talked about this 24-hour thing before too. But then again, then you see this horizontal line here. Why are we seeing horizontal lines? I've not seen this. I've seen a horizontal line on here before, like this small one right here. But when we see something lasting that kind of a time frame, and then we start seeing stuff like that, and then we see this, that's even hidden in there. They're not hiding it, but that's hidden in there where you almost can't see it. Okay? So I wanted to show that to you too. I don't know what that is, guys. I really don't. I'm not sure if anybody else has done videos on that yet. I can't remember. Obviously, I haven't had a whole lot of time to watch a whole lot of videos, but that is what it is. Scott did put out a video talking about, well, you know what? Let's just do this real quick. We're not going to watch it. I'll point you guys over to it. Oh, man. Yeah. Okay. So we go to his videos. Okay, it says Solar Watch. 3 active regions on the sun are now blending together. We're going to click on that. Okay. So yeah. So those are the active areas. That's at 2740 and 2741 that basically made 2 laps around the sun. Kind of fizzled out. Then they kind of came back, and now they're kind of becoming one. All right. Like I said, if you look at this is yeah, they're kind of blending together to one big active area. There was separation there, and it's not there anymore. But something else that I've been noticing is these coronal holes. Okay, I think we need to watch these. I really do. This one over here, probably not so much because it's going in that direction, which would be away from Earth facing. But this one up here, that's actually kind of higher to the north than what we would typically see a direct hit from solar winds. But if it does grow down a little bit down this way, I mean, you can look. I mean, for whatever reason, guys, the coronal holes seem to be popping here. I don't know why, but we're seeing dark regions kind of come and go. And that's pretty typical, but I've seen some pretty large ones that seem to happen at weird times. And then something else, I need to talk to Scott about this one because I'm trying to figure out why this is doing it. Or if anybody else has any ideas, be more than happy to listen. This right here is this tool I show you guys all the time, right? Sorry about that, guys. Had to answer the phone. Anyway, I show you guys this tool all the time. This is the magnetosphere tool that I show you guys. What I typically don't show you guys is the actual chart, the graph here. Okay, what we're looking at here, guys, is the ion density. Okay. You see where it says 15 to 45 right here? Typically, that says 2.5 to like 5. Okay, they adjust this chart so this line graph doesn't look so funky, like jumping way up and down. I don't know why they seem to think that that's necessary. I don't know the reasoning behind that. Maybe it's so people don't freak out when they get on here and they see like a 2.5 jump way up to like almost a 50. You know, so if you can kind of shorten that, you can see how the peaks and valleys on this wouldn't be as extreme. But the ion density here, guys, is crazy high. Okay? It typically stays between 2.5 and 5, like I just said. This is up at 45. Okay, it's hanging around 30, 35, you know, as an average here. But it's even spiking higher than that. Okay? Ion density, what is that? Okay, I get that question quite a bit, actually. Well, we talk about solar wind speeds and how it affects our magnetosphere, our shield, right? Well, the way I've explained this before in the past is that the more dense the ions are that are hitting the Earth, coming from the sun, basically it's like taking, say, typically you would use a 10-pound bowling ball when you went to the bowling alley. And you would throw it at, say, 10 miles an hour, correct? And you hit these pins and, say, 8 of them fell down. Well, if you take a 16-pound ball, double the weight, and you even throw it slower, but yet you get a strike, you knock all 10 down. That's kind of the correlation here between wind speed and density. Now, say you took that 16-pound ball and you threw it the same speed as you were throwing the 8-pound ball, then we're really talking about some damage. Okay? That's when we get really concerned. But what I'm trying to say here is that solar winds themselves can cause disruptions in the magnetosphere, okay? But so can just high density, okay? That's what I want to, that's my point here, okay? You don't have to have high solar wind to have issues like this, okay? This right here is the real-time data. This is what it looks like right now. Okay? Obviously, you guys can see that that's pretty intense. So when we see that, the first thing we look at is solar wind. Okay, what's our solar wind supposed to be at? Well, it typically hangs around 300. Okay? Usually between 250 and 350. Alright? There's your solar wind speed. It's normal, guys. So why are we having all this disruption? It's because our ion density is higher. The ions are heavier, basically. I don't want to put it in forms of weight, but it's more dense. Yeah. That's what happens. And so when you look at this. This is all kinds of odd. It's like we don't even, look at this, guys. It's like our shield is almost gone, or at least it ain't being affected, because the only place we're seeing heat is right there. Now, we still have a bow shock out here in the front. It's very, very weak looking. But that could be just because we're not getting pelted. Because what you're seeing here is heat. So when charged particles hit our magnetosphere, it generates heat. That's what this graph is showing, basically. Okay? Or this model. So that's how we look at this, and they indicated it by giving you a range here of blue to red. Okay, blue being low, red being high. So there you go. So right now we're getting hit right here in this area just a little bit by something, but the rest of it looks pretty like almost neutralized, if I could use that word. Okay, it's like we're able to just be okay with where we're at. Now we'll go down here and see. Now this is where it gets strange for me, because these are not typical signatures. Okay? Now what we're looking at here, guys, when we're looking at this, see how it says Northern Hemisphere, this is Southern. This is looking at the top and bottom of the Earth. Okay? typically you'll see a blue and a red. Almost like a yin and a yang, you know, the Japanese symbol. But and I've seen this before, so it ain't like this hasn't ever happened. But I'm seeing two blue areas, and they're almost spiraling around, you know, two higher areas. And it really shows up right here. Look at this. Okay? This right here is an odd signature. This shape itself is extremely odd. Okay? So if we scroll down here, now look at that. Here's your density, real time right here. It went all the way up to 50. They changed it and made the graph. They had to make the graph go up to 50 right here. Then you see how it drops off back to 25 and it starts coming back up. All right. So what's causing that? Well, I mean, whatever's coming from the sun or other stellar objects could be causing it. All right. Now, if you look right here, guys, I mean, you're going to see when density goes up, typically the solar wind speed goes down, and then vice versa. So kind of keep that in mind. But why I'm finding this all strange is because our solar wind speed is not getting that high. But yet we're still getting hit really, really hard by something. Okay? It's affecting our magnetics pretty severely here. And that's what I'm trying to say. So, for those that think that the only time that we get, you know, bad solar stuff is from high solar winds, that's just simply not true. We can have magnetic disruptions by ion density also. Basically particles getting shot at us. Okay? Even though they're moving slower, they're still high energy particles. So, there you go. But, anyway guys, go over and check out Scott's video. Go watch his articles over there on planetxnews.org. Go check out Jeff P. too. He's been putting out some videos on lightning and what he thinks going on there. It's pretty cool. Go check that stuff out. And I'll leave some links to all this stuff. And yeah. But yeah, the main reason I did this video today, guys, is because of this. Okay, that was back on the 5th. You know, here it is. Objects showing up again. Again, there you go. God bless. Yeshua saves, and you can drink this Kool-Aid.